morning, back with our classes on magnetic effect of electric current. So from the beginning we will again start. We said that Oersted experiment basically tells that electricity and magnetism are interrelated phenomena. You take a circuit and take a circuit with a plug key, switch on the circuit, you will find that the current flows from positive terminal to the negative terminal. If you get a magnetic compass near the current carrying conductor, it always deflects. This is because the current carrying conductor behaves like a magnet and generates its own magnetic field. Clear? So this was shown by Hans Christian Oersted, which state that electricity and magnetism are interrelated phenomena. His work is widely used in fiber optics, radio and television, and hence to honor him, the magnetic field strength unit is named as Oersted. First page over. Now come to second page. Second page of your textbook says properties of a magnet. Yesterday only I taught the naturally occurring magnet is called what? Lodestone. What is the formula of lodestone? Fe3O4. Okay, then we also studied that whenever you hang a magnet, it will always point towards north and south. So when a magnet is freely suspended, it always points towards north-south direction. Like poles of a magnet repel each other, and unlike poles of a magnet attract each other. When the magnet is cut into many pieces, each piece behaves like a magnet and the poles are induced. You may have many types of magnet, as spherical magnet, bar magnet, and also we have some magnet which is called, this magnet is called what? Horseshoe magnet. Okay, then we studied properties of magnet. Then we have to study what? How to draw magnetic field. So the first activity what we study to draw magnetic field is take a kg cardboard and place it on a drawing table or a wooden table with the help of thumb pins. Okay, sprinkle what? Iron filings around it and place at the center a bar magnet. You will find that iron filings arrange themselves in the form of what circles? Concentric circles, which shows that the area around the magnet where the magnetic force can be felt is called as magnetic field. So as long as you can keep drawing magnetic field lines till that edge, it is called as what? Magnetic field. We can also draw the same magnetic field lines by using what? A compass needle. We take a magnet and then keep on placing the magnetic compass which keeps directing what? North pole. So we say magnetic field line is the path taken when the free north pole tends to move across a magnet. What are the properties of magnetic field line? They are closed curves moving from north to south outside the magnet and south to north inside the magnet. They crowd near the poles and hence poles are the areas of strong magnetic field. They never intersect each other because at the point of intersection, if you get a magnetic compass, it shows two directions of magnetic field, which is practically impossible. Correct? Magnetic field is what quantity? Vector quantity and has both magnitude and direction. Correct? Now the next page. Magnetic field due to current carrying conductor. When you actually try to find magnetic field due to current carrying conductor, you use which rule? Snow rule, which states when the current flows from south to north over the needle, the deflection of the needle is towards west. When the current flows from north to south over the needle, the deflection of the compass needle is towards east. So this basically tells you the direction of magnetic field in a current carrying conductor. Now, today we will study direction of magnetic field due to a straight conductor. Okay, so what we have to study today, illivargu clear, whatever we have studied. So today we will study magnetic field due to a straight conductor carrying current. So how do we analyze magnetic field due to a straight conductor carrying current? Let us understand, this is my wooden table, or I can say a kg cardboard. Fine, I'll make a hole at the center. Okay, so same thing I am drawing here. So this is my kg cardboard or a wooden piece, and this is the center. So what I have drawn, I have made a hole at the center. Okay, from the hole I will pass a wire. Fine, so I am passing a wire through the hole, and then I am connecting this to a source, which is a cell or a battery, and I am using what? A plug key. Is the diagram clear? I can even have a rheostat, pi rheostat, to change the resistance, and I can even have what? An ammeter to connect the circuit. Is it clear? These are not needed exactly, but these can be included so that we can change the current. Okay, so what I have done, I have taken a cardboard, I have made a hole at the center, I have put a straight wire carrying current through it. This wire is connected to a cell or a battery using what key? A plug key, an ammeter, and a rheostat. Rheostat basically will change resistance, and hence the current will also change. More the resistance, less the current. Less the resistance, more the current. This much we have learned. Now, after that what I will do is, I will sprinkle some iron filings around it. Then, I will pass the current and will wait and observe the movement of iron filings. Okay? So now, when I have to do this, I generally follow a rule to judge the magnetic field. To judge the magnetic field in a straight conductor carrying current, I generally use what rule? Right hand thumb rule. Right hand thumb rule. Okay, this is the rule which we will use. The second rule which we study is Ampere's swimming rule, which we will not study. I am only teaching you the name. Ampere's swimming rule. Or we also can find out using Maxwell corkscrew rule. So to find out the magnetic field in a straight conductor carrying current, I will use right hand thumb rule, which is what we will be asked. I can also use Ampere's swimming rule. I can also use Maxwell corkscrew rule. Only these names are required. Lot of schools will teach all this, but it is not to be asked in this level. Only we should know what? Right hand thumb rule. So now, what is right hand thumb rule? And right hand thumb rule is not with any scientist. Fleming's right hand thumb rule madbirtira ನೀವು, but athara ಏನಿಲ್ಲ. It is just what? Right hand thumb rule. So always, how you should start? So state the right hand thumb rule. Hold a straight conductor carrying current. Sathoktira. Nobody goes and holds. And all of you write like that only. Apna hi kheti hai. Hold a straight conductor carrying current. Imagine you are holding. You cannot go and hold a current and then do that center fresh add. Okay. So always understand. If you will start with, imagine you are holding a straight conductor carrying current in your right hand in such a way that the thumb shows the direction of current. Imagine you are holding a straight conductor carrying current in your right hand in such a way that the thumb shows the direction of current. Then the wrapped up fingers or the curved fingers shows the direction of what line? Magnetic field lines. Aita, iga nodi. when it is flowing from north to south. The field lines are what wise? Clockwise. When it flows from south to north, field lines are what? Anti-clockwise. Opening in the nodbeku. Field lines are anti-clockwise. When it flows from east to west, field line is from north to south. When it flows from west to east, field line is from south to north. Artha aita? Pakka? Matte. What is right hand thumb rule? Imagine you are holding a straight conductor carrying current in your right hand in such a way that the thumb shows the direction of current and the wrapped up fingers or the curved fingers shows the direction of magnetic field lines. If the current flows from north to south, the curved lines are clockwise. If it flows from south to north, it is anti-clockwise. So here the current is flowing from what? South to north. So how will it be? Anti-clockwise. Gottaita? This is anti-clockwise. Yes or no? Clockwise is like this. It is going ulta. So it is called what? Anti-clockwise. If it was flowing from north to south, how it would have been? Clockwise. Did you get my point? So if it is from north to south, it will be what? Clockwise. If it is from south to north, it is what? Anti-clockwise. Is the logic clear? So this is what, how to find out magnetic field in a straight conductor carrying current. Take a cardboard, make a hole at the center, pass a straight conductor carrying current through it, and then connect it to a plug or a battery using a cell, a rheostat and an ammeter. Sprinkle some iron filings over it, switch on the current and allow them to arrange themselves. You will find they arrange themselves in the form of concentric circles. The direction of the magnetic field in a straight conductor carrying current is given by right hand thumb rule. It states, imagine you are holding a straight conductor carrying current in your right hand in such a way that the thumb shows the direction of current, then the curved or the wrapped up fingers shows the direction of magnetic field lines. When the current flows from south to north, it is anti-clockwise. When it flows from north to south, it is clockwise. Is it clear? Understood? Now we will read this part. Magnetic field due to a current through a straight conductor. What determines, ಇದನ್ನು ಅಲ್ಲೇ question ಬರೀರಿ. How is magnetic field due to a current through a straight conductor detected? How is magnetic field due to a current through a straight conductor detected? Done? So now what we will do is we will read this. You have to write the entire activity in your notebook in very short ways as we spoke. Okay, you don't have to write exactly how it is given. Take a battery of 12 volt, a variable resistance or a rheostat, an ammeter, a plug key and a long straight thick copper wire. Ille nodabodu diagram alli long straight thick copper wire, a battery with 3 cells, 12 volt, a plug key, an ammeter and a rheostat. Insert the thick wire to the center normal to the plane of a rectangular cardboard. Take care that the cardboard is fixed and does not slide up and down, because if you do that, the iron filings will fall. Connect the copper wire vertically between the point X and Y as shown in figure 13.6. ಅಲ್ಲಿ ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಕೊಟ್ಟಿದ್ದಾನ ನೋಡು, ಕೊಟ್ಟಿಲ್ಲ ಅಂದರೆ ಮೇಲೆಯಿಂದ ಕೆಳಗಡೆ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಳ್ಳಿ, ನನ್ನ ಬುಕ್ಕಲ್ಲಿ ಇಲ್ಲ. Sprinkle some iron filings uniformly on the cardboard. You may use a salt sprinkler for this purpose. Keep the variable of the rheostat at a fixed position and note the current through the ammeter. Close the key so that the current flows through the wire. Ensure that the copper wire placed between the point X and Y remains vertically straight. Gently tap the cardboard a few times to observe the pattern of iron filings. That the iron filings align themselves, showing a pattern of concentric circles around the copper wire. What do the concentric circle represent? They represent what? Magnetic field. Magnetic field lines. How can the direction of the magnetic field be found? Place a compass at a point P over a circle. Observe the direction of the needle. The direction of the north pole of the compass needle would go towards the direction of the magnetic line produced by the electric current through the straight wire. Does the direction of the magnetic field lines get reversed if the direction of the current through the straight copper wire is reversed? Yes, it will change. If the direction is changed, if the direction of the current is changed, the magnetic field will also change. It will change. What will happen if the current is increased? The magnetic field lines will be stronger. How will we know it is stronger? They will become closer to each other. If I have less current, then magnetic field lines will be something like this, far away from each other, showing what? Weak magnetic field lines. But if I increase the current, magnetic field lines will be very, very close, which indicates that the magnetic field is strong. Understood? Now, what happens to the deflection of the compass needle placed at a given point if the current in the copper wire is changed? To see this, vary the current in the wire. We find that the deflection of needle also changes. In fact, if the current is increased, the deflection also increases. It indicates that the magnitude of the magnetic field produced at a given point increases as the current through the wire increases. What happens to the deflection of the needle if the compass is moved from the copper wire but the current through the wire remains the same? If I had kept the compass here, the deflection will be very strong. Why? Because it is very close to the current carrying conductor. But if I keep it somewhere here, then the deflection becomes less as the magnitude of the magnetic field decreases as you go away from the center of the wire or from the wire. Okay. We see that the deflection in the needle decreases. Thus, the magnetic field produced by a given conductor decreases as the distance from it increases. It can be noticed that the concentric circles representing the magnetic field around a current carrying straight wire becomes larger and larger as we move away from it. ಈ full paragraph ಮುಂದೆ ಬರೀರಿ. What are the factors that affect magnetic field by a straight current carrying conductor? By a straight current carrying conductor. Okay, so the first name baritira. Magnetic field is denoted as B. Fine, magnetic field is generally denoted as B. So first point name baritira. B is proportional to I. What does it mean? As the current increases, magnetic field also increases. Then second, B is inversely proportional to 1 by R. Distance from the wire. This is the radius, no? Right? So what happens? As the distance increases, magnetic field decreases. So B is inversely proportional to 1 by R. B is proportional to I and B is inversely proportional to R, where R is the distance from the wire. Where R is distance from the wire. Artha factor affecting. So if I increase the current, magnetic field increases. If I move the distance away from the wire, then the magnetic field decreases. Now, there is a logic that this right hand thumb rule is, some teachers teach, this right hand thumb rule is also known as what? Maxwell corkscrew rule. Okay, but corkscrew rule can also be explained in a different way. So this right hand thumb rule is sometimes also called as Maxwell right hand thumb rule, or just learn it as right hand thumb rule. This is also called as what? Maxwell corkscrew rule. So what did we study today? Right hand thumb rule, which states that imagine you are holding a straight conductor carrying current in your right hand in such a way that the thumb shows the direction of current and the wrapped up fingers shows the direction of magnetic field lines. When you pass current through a straight conductor, magnetic field lines arrange themselves in the form of concentric circles with the wire at its center. If I want to increase the magnetic field in a straight conductor carrying current, I should first increase current. If I increase current, magnetic field increases. If I reduce the distance from the current carrying conductor, magnetic field increases. If I increase the distance, magnetic field decreases. Everything about straight conductor carrying current clear? First, the activity. You can write the activity in your own words. It is not essential to write exactly the same way. You can write, take a cardboard, sprinkle some iron, make a hole at the center, pass straight. Diagram important appa. Which diagram? Figure 13.6a. Figure 13.6a important. Okay. So you will write the activity, draw the diagram, and you will say the rule governing straight hand rule is, or rule governing the straight conductor carrying current is right hand thumb rule. You will write the right hand thumb rule. So we will read the right hand thumb rule. Imagine that you are holding a current carrying straight conductor in your right hand. Please write that word imagine. You cannot hold the straight conductor carrying current in your right hand. Okay, such that the thumb points the direction of current, then your fingers will wrap around the conductor in the direction of field lines of the magnetic field. Then you can say the wrapped up finger shows the direction of magnetic field. This is known as right hand thumb rule. Kelgade nodi kottidare. The rule is also called as Maxwell corkscrew rule. If the direction of the current, then the direction of the corkscrew is the direction of the magnetic field. Idu odbedi. Just remember, it is also called as Maxwell corkscrew rule. Clear? So right hand thumb rule. Pakka? How do I change the magnetic field? By changing the current. And by also changing the radius or distance from the wire. If I increase the distance, magnetic field decreases. If I reduce the distance, magnetic field increases. What distance? Of keeping a compass needle. If I keep a compass needle closer to the current carrying conductor, the deflection is more. If I keep the magnetic compass further away from a current carrying conductor, the deflection is less. Because as I go away from the current carrying conductor, my magnetic field lines become larger and larger, and the magnetic field decreases. Is it clear? Pakka? We will stop here and study magnetic field due to a circular conductor tomorrow. There is no hurry in doing it until and unless you understand it. Okay? And please, I think these questions, draw magnetic field lines around a bar magnet, done. List the properties of magnetic lines of force, done. 3 properties. Why don't 2 magnetic lines of force intersect each other? Because at the place of intersection, if you place a magnetic compass, it shows two directions of magnetic field, which is practically impossible. Example 13.1 ಮನೆಗೆ ಹೋಗಿ ಮಾಡಿ. ಅರ್ಥ ಆಗ್ತಿದ್ರೆ ಕೇಳಿ. ನಾನು ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ ಈಸ್ಟ್ ಟು ವೆಸ್ಟ್, ವೆಸ್ಟ್ ಟು ಈಸ್ಟ್. ಅದನ್ನ ಒಂಚೂರು ಪೆನ್ಸಿಲ್ ಹಿಡ್ಕೊಂಡು ಮಾಡಿ ನೋಡಿ. ಅರ್ಥ ಆಗದಿದ್ರೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಇಷ್ಟವರೆಗೂ ಫುಲ್ ಬಾಯ್ ಪಾಠಲ್ಲಿ ಬರಬೇಕು. ಎವ್ರಿಥಿಂಗ್ ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್, ಸೊ ಪ್ಲೀಸ್ ರೀಡ್ it. If you understand it, it's a beautiful chapter. And second year, 4 chapters are based on this physics. So if 10th physics, electricity and magnetism is not understood, 12th physics, you will be, what I should say, Chombeshwar, Dhamar. All those people in Pushkarni will tell. Full hoge, okay, whatever you want to say. So physics correct, I would make 10th. Fine, thank you.